Let's talk about key value RDDs. Very common thing to deal with, so we want to understand how they work. Basically, any time that you have to aggregate information down to some key value, you're going to be using key value RDDs. For example, let's consider a case where we need to figure out the average number of friends broken down by age in some fake social network that we have. So let's imagine that we have a data set that's for each person has their age and how many friends they have, along with whatever else information we might have. Okay. Now, if I want to actually figure out the average number of friends broken down by age, I need to somehow aggregate all of the friend counts for every given age. So in this case, the key is the thing that we want to aggregate on, the age, and the values will be the things that we're aggregating, the friend counts. So we want to aggregate together all these friend counts broken down by age and end up with what's the average number of friends a 20-year-old has for the key 20, what's the average number of friends that a 33-year-old has for the key 33, and so on for all the other ages. Okay. So how does that work? Well, syntactically, all we need to do is represent values as not just a single value, but as a tuple of two values. So in our previous examples, we had RDDs where every row represented a line of input text or every row represented an integer or something. You can also represent a tuple. And if that tuple contains two objects, then Spark can treat that automatically as a key value pair. And there are some special things it can do with that sort of information. So let's look at this example here. In this case, we're taking an RDD that contains perhaps one bit of information per row and transforming it into a key value RDD. And all this transformation function is doing is mapping RDD where each line x gets transformed to the tuple x1. So that's creating a key value pair of x, the original value, that's the key, and the value 1 for each row. Okay? And that's it. There's nothing special beyond that. You now have a key value RDD just by the fact that you are storing tuples with two things in them. And you can actually store even more complicated structured data as well. If you can still have a tuple where you have some value as the key and some more complex tuple as the value. So you can nest information and structure it as complicated as you want, but at the end of the day, as long as you have at the top level two things, a key and a value object of some sort, that counts as a key value RDD. Now, what can you do when you have a key value RDD? A bunch of things that you couldn't normally do. One very common operation is reduce by key, and this allows you to provide any arbitrary function you want for combining values together and grouping them together by key. So in this example here, take a look at the syntax. We're actually taking a tuple xy here, okay, and transforming that to x plus y. Now this is a little bit confusing, so stay with me here. Xy here does not represent a key value pair. It actually represents two values that need to be combined together. So reduce by key is saying, okay, I want a function that will take two values for the same key and define how these things get combined together in my new RDD. So let's say that I just want to add up all of the total friend counts for everyone who's 20 years old. I might hit this for the key number 20. The key 20 never changes. That's going to be automatically transferred over to my new RDD, but what does change is the value, where I'm going to aggregate together all of the values for key 20. So this function says, given two values for the same key, how do I combine them together? In this case, I want to add them together, and that will take every value found for a given key and add them all up, two at a time. Okay? Why is it two at a time? Well, remember, this might be distributed, so we can't just take everything all at once and add them all together in one big function. It has to do a piecemeal, one bit at a time. So we need to tell Spark, given a running total and some new value, how do I combine them together? And that's what this function does. It'll make more sense when we look at some code. We can also do group by key, and if you don't want to actually aggregate all these values together for a given key, you can group them all together into a big old list. And that's what group by key does. So if I just want to collect together all of the values seen for a given key, group by key will return an RDD that is just that. It will give you back key values where it gives you each unique key, and the values will be a list of all the values associated with that key. Okay. We can also do sort by key, which will just sort an RDD by its key values. Very straightforward. And you can also retrieve individual RDDs of just the keys or just the values of a key value RDD, and the keys and values functions will do that for you. Some other things you can do, you can actually do SQL-style joins if you have key value pairs. I mean, if you think about it, a key value RDD is kind of a lot like a NoSQL database, isn't it? And we can do some database-like things since we have some more structured data now. You can do joins of various flavors, And we'll look at some examples of that later in the course. A little bit too complicated to get into now, but just know that it is possible to do SQL-style joins when you have key-value RDDs to work with. One other thing, if you're just going to be mapping the values in a key-value RDD and you're going to leave the keys alone, it's going to be more efficient to use the functions map values and flat map values instead of just map and flat map. Okay? So if you're going to map just the values of a key-value RDD, use map values and flat map values, it will be simpler from a syntactic standpoint and also more efficient. So let's dive into an example to make this all real. I mean, it's nice to talk theory and all, but it doesn't sink in until you actually do it, right? So let's imagine, if you will, that we have some social network data to play with, and each row of information in our raw input data looks something like this. So we have a bunch of comma-delimited rows of information that consist of a user ID number, the user's name, the user's age, and the user's number of friends. Okay, and you can probably tell from this fake data that I'm one of those weird Star Trek fans that you hear about, and probably are best to avoid. So what we're trying to do, again, just to remind you of the purpose of this example, we're trying to find the average number of friends for a given age. So in this case, we have Will is a 33-year-old in our fictitious data, and so is Jean-Luc. And Will has 385 friends. He's super popular. Jean-Luc, he's a little bit socially aloof, so he only has 2. So we want to somehow figure out how to combine these 2 guys together, because they both have the same age, and figure out their average number of friends, and so on for the remaining people in our data set as well. So let's look at some code. How do we get started? Well, again, the first thing you want to do is parse out your input data and throw away the data you don't need. So that's what we're going to do with our parse line function here. Given a line of input data, we're going to split it up based on the comma characters that we find in it. And we will access fields number 2 and 3. And remember, that's actually the 3rd and 4th fields because we start counting with 0 here. And we will transform that field number 2 to an integer and interpret that as the age. And field number 3 will also be interpreted as an integer, and we'll store that as the number of friends for this person. And what we'll return is a tuple, a key-value pair, of an age and a number of friends for this person. Now notice we've completely discarded the user ID and the user name from that input data because it's irrelevant to the problem we're trying to solve. All we want to know is what's the average number of friends for a given age. Who these people are doesn't matter, right? So when we're done with this step, basically we take sc.text file and load in our raw data, and then we map using that function we just wrote, and it gives us out something like this. So from our input data, we end up with a key value RDD, where the keys are the ages for each individual and the values are the number of friends for each individual. So we haven't done anything to aggregate things together yet. All we've done is create a key value RDD in preparation for the operation we need to do. So now what happens? Well, things get a little bit fancy here. So take a look at that big scary line of code there. It's a little bit intimidating, you know, but it is a common practice in Spark scripts to chain things together in this manner. So if you look at it, we're actually taking the RDD, the key value RDD of ages and number of friends. We're calling map values on it to just transform the values of each one. And then we're chaining together yet another operation on top of that with a dot reduce by key. So basically this is saying start with our key value RDD of individuals, ages, and number of friends. We're going to map that using this function here, and then take the resulting RDD from that step and apply reduce by key to it as well. So we're basically doing 2 steps in one here. Pretty common thing to see. But let's break it down into its components and talk about what's going on. So the first part of this statement is rdd.mapValues using a transformation function of x to x, 1. So all we're doing here is saying transform each number of friends to a tuple that contains the number of friends and the value 1. So what's the method to our madness here? Why am I doing that? Well, we need to end up with the average number of friends in the end, remember. And to compute an average, you need 2 numbers. You need the grand total, and you need the number of instances, the number of things that you added up, and divide those 2 things to get the average. So thinking ahead a little bit, what I'm going to do is transform all of these key value pairs of age to number of friends to a slightly more complicated format here, where the key is still the age, but the value is now a tuple itself, that is the number of friends and the value 1. And you see what happens when I start to add these all together. So if I add together both fields of these tuples for each given key, I will end up with both the grand total of how many friends in total all the 33-year-olds in the world had, and I'll also end up with the number of 33-year-olds in the world, okay, because I add up all those ones for each individual that I saw. That's what I'm trying to do here, and that's what reduce by key does in this next clause of this expression. So that's going to take two of these values, okay? So remember, reduce by a key, the x and y is not a key value pair, it's two different values. And in this case, the values are two different tuples, where the first value is the number of friends and the second is the number 1. I'm going to apply this function to add them together, where I just say the result will be the addition of the two number of friends coming in and the two number 1s that come in. Okay, so as we keep a running total over the entire data set, what we end up with is a grand total of how many friends in sum all the 33-year-olds in the world have and how many 33-year-olds there are in our data set. And of course, it will do that for every unique key automatically. Makes sense? A little bit complicated. This is the most complicated thing we've done so far in the course. So if you do need to go back and stare at this slide some more, don't be afraid to do so. I won't judge. All right, next thing we need to do is actually use that information to compute the averages themselves. So remember, at this point we have key value pairs where the keys are the ages and the values are the grand totals of the number of friends and the number of people of that age. All we need to do now is divide those two to get the averages, and that's what this map values function does. It says for a given value, which in this case is one of these tuples, we're going to just take the first field divided by the second field to get our final result. So in this particular example for 33-year-olds, we might end up with 33, the age 33. We're going to take out the value and map it to just divide these two fields. 387 divided by 2 works out to 193.5. And we end up with a final result for 33-year-olds having an average number of friends of 193.5. Not sure what half a friend looks like in reality, but let's not go down that line of thought. It's a little bit disturbing. Finally, we need to collect our results. And remember, nothing happens until we actually call an action. So we're going to collect the results here into a plain old Scala object, and then we're going to sort it and apply the print line command to each individual entry. And we get the final results that way. So with that, let's go take a look at the actual code.